Oh, that's not it. That's science. All right. So, as we were saying, for solving, we can root something in order to solve it. So the first example that is there says x squared minus 4. That is something you can factor. It factors by difference of squares. So you can factor that as x minus 2, x plus 2. And in doing that, you get the answers of x equals positive 2 and x equals negative 2. Or you could write that as x equals plus and minus 2. So you can get the answer of plus and minus 2 by factoring. However, you can also solve it this way. So if we had x squared minus 4, you bring the 4 to the other side. Then you square root each side because the square root of x squared will leave me with just x. And what you do to one side, you have to do to the other side. So I square root each side, and the square root of 4 is also plus and minus 2. And if you don't know why it's plus and minus 2, it is because negative 2 times negative 2 will also give you an answer of positive 4. And that is true for any even numbered exponent. So for any even numbered exponent. So for instance, if I had negative 2 to the power of 4, negative 2 to the power of 4 is going to give me positive 16. But negative 2 to the power of 3, an odd numbered exponent, what does that give me? Does it give me positive 8? No, it gives me negative 8. All right, so if it's an even numbered exponent, even and negative will give you a positive answer, which means for any even numbered radical, you'll have two answers. Okay, more on that in a little bit. Next, so if we were solving here, I have x to the power of 3 equals 8. I want to take the cube root of each side. The cube root of x cubed just leaves me with x. And then the cube root of 8 is positive 2 only for the reasons that I just explained. So your answer there is only positive 2. Then for the fourth root, so x to the power of 4, I can take the fourth root of x to the power of 4. It leaves me with just x. Then because I took the fourth root on this side, I have to take the fourth root on this side. So in your calculator, you would plug in the fourth root of 81. You all should have that capability. If you're not sure how to do it in your calculator, I can come around later and show you. However, I also made this lovely list at the top. So which of these numbers to the power of 4 was equal to 81? 3. So my answer to the fourth root of 81 is it just 3? Plus and minus 3, because it's a fourth root. Even numbers would do that. Anything with an even number in the index, you'll have a plus and minus answer. If it's odd, that's not true. Just even numbered ones. Okie dokie. Now for the fun stuff. So here's the skill that you should have learned in grade 10. So we are going from what is called entire radicals to mixed radicals. So these are called entire radicals because they are entirely under the radical symbol. So they are called entire radicals or whole radicals. You'll hear both terms. And we are going to change them to what is called mixed radicals. There are technically two strategies for this. Well, there's technically a couple strategies, but there are two main strategies that you would have learned in grade 10. I am concentrating on one of those strategies only. That is all I'm going to show today. If you are struggling with it, come see me and I can show you some of the other strategies, but I am sticking to one strategy only. And that is breaking this number down into its perfect squares. So yes, I could say that 20 is the same thing as 2 times 10. 2 times 10 will not help me because neither 2 nor 10 are perfect squares. So what's another way that I can break 20 down that also includes a perfect square? Connor? 4 times 5. Good. And then for this first example, just to really slow things down, I'm going to break it down even more. So 4 times 5, I could also write that as radical 4 times radical 5. Those mean the same thing. And then the reason why that makes it a little bit easier at first is we can actually break it down. So what's the square root of 4? 2. And then radical 5 can't be simplified anymore, right? 5 is a prime number. There's definitely no perfect squares hidden within 5. So this means 2 times radical 5. Now these radicals work similar to algebra. That's why I keep kind of going back to it. So if you had 2 times x, how would we write 2 times x? 2x. Yeah, it's not a trick question. You would just write 2x. So how are we going to write 2 times radical 5? We're just going to write 2 radical 5. They mean the exact same thing. Just like 2 times x means 2x, 2 times radical 5 means 2 radical 5. Okay, so we're going to do the same thing to 12. So 12 would be 4 times what? 3. Square root of 4 is 2. Radical 3 can't be simplified anymore, so we write it as radical 3. Yes, I didn't show all of the steps that time. I feel like the first one is sufficient. So square root of 4 is 2. Radical 3 can't be simplified anymore, so that's 2 radical 3. Now, 200 brings up an interesting point. So there's actually a bunch of different ways that we could break down 200. So 200 could be written as 4 times what? 4 times what to give 200? 50. Now, you could do that. However, does 50 not have another perfect square in it? Yeah, 25, right? So you could break it down this way, but then you're going to be stuck with another radical that you have to break down again. So what you want to do is not only do you want to be looking for perfect squares, but you want to find the biggest factor that is also a perfect square. Just like if you had a fraction that was, say, like 100 over 200. You could definitely divide that by 2. You could continue to divide that by 2 until you got to 1 over 2. Or if you find the greatest factor, you can get to 1 over 2 in one step. It's the same kind of principle. You can divide 200 any way you want and eventually get to the right answer. It's just going to be a lot more steps. But if you find the biggest factor that is also a perfect square, you're going to get to that answer faster. Okay, so think of 200. I also just kind of gave you a bit of a hint. What's the biggest perfect square that I could times to get me 200? Yeah. 2 times 100, exactly. Now it technically doesn't matter, but I like to write the perfect squares first. So instead of 2 times 100, I would write 100 times 2. It technically doesn't really matter, but it's just a personal preference. So 100 times 2, the square root of 100 is 10. And then I can't simplify radical 2 anymore, so it just stays a radical 2. Does that make sense? Awesome. And just really quickly, so this part you don't have to write down, you can just watch. If I had done the 4 times 50, I just want to show you that it still would have worked. So 4 times 50 would have given me 2 radical 50, and then radical 50 would have been 25 times 2, so you would have done 2 times 25 times 2. 25 is 5. 2 times 5 is 10. So you still would have gotten down to 10 radical 2. I don't care which method you do. If you gave me this on an assessment, you would get full marks because you showed your work, you showed me that you got the right answer. It's just that obviously this is faster, right? So both are equally correct. There is no one that is really better than the other. They both get you that answer of 10 radical 2. Okay, 80. There's a lot of talking. 80 can be 16 times 5. Someone just asked in the chat, couldn't you have done 25 times 8? Yes, absolutely, same principle. You could have done 25 times 8, and eventually you still would have gotten 10 radical 2. It does not matter which factors you pick, as long as you break it down completely. So 80 would be 16 and 5. Again, that's another one where you could do it different ways, but 16 and 5 are the biggest factors that will get us down faster. Square root of 16 is 4. And and then I'm left with radical 5. And I say biggest as in like greatest perfect square that is also a factor. Someone last class said like 40 and 20 is bigger than 16, but 20 is not a, like, if we're looking at the perfect squares, 16 is a bigger perfect square compared to 4. That's what I mean when I say the bigger one. You want the bigger factor that's also a perfect square. Okay, oh my god. Cube roots. So the cube root of 144. So now I'm not interested in breaking them down into perfect squares. I'm interested in breaking them down into perfect cubes. And that's why I got you to write out that list. Because yes, you probably know them, but I doubt you have them memorized the same way you have the perfect squares memorized. So having that list is helpful because then you're going to go, okay, 144 is what I want to break down. All right, let's try. 144 divided by 8. Does 144 divided by 8 work? What's 144 divided by 8? I think someone said it. 18, good. So I'm going to do 8 times 18. And then it's a similar principle. The cubed root of 8, so this is our first one, so I'll write it out. The cubed root of 8 times the cube root of 18. Cube root of 8 is 2, and then I'm left over with a cube root 18 that I can't break down anymore. So it just stays cube root 18. So my final answer would be 2 cube root 18. If you don't include that 3 in the index, your answer is wrong. And it's not me being picky. There's a difference, right? 2 square root 18, well, square root 18, there's another perfect square in 18, right? 9 times 2. So if it was 2 square root 18, that would mean you're not done the question. 2 cube root 18, there's nothing I can break down any further. That's the end of my question. Okay, so it actually makes a big difference. You need to make sure you include that index number. Alrighty, I forgot to erase those ones. 40. Again, you're only interested in your cube root, so you do 40 divided by 8. Oh, that's 8 times 5. So cube root 8 times 5, cube root of 8 is 2, and then there is a cube root 5 that I cannot simplify anymore, so that means my answer is 2 cube root 5. $162. The index number is 4, which tells me that I'm only interested in these numbers. So I would do 162 divided by 16. Might give you an answer, but then you're going to look at the next one and see if you get another answer. Does 162 divided by 16 work, just out of curiosity? No? Okay, anyway. Even if it did, you might have been left with like a big number, so then you go down to the next one, you do 162 divided by 81, and 162 divided by 81 is 2. Should have known that. So 81 times 2 gives 162. So even if the first one had worked, what am I doing? This one gives us a smaller number left over. So the fourth root of 81 is, what was it again? 3. The fourth root of 81 is 3, and then I have a fourth root of 2 left over that I can't simplify anymore. So again, the next one has a 4 in the index, which means we're looking at that list of 2 to the power 4, 3 to the power 4, etc. 2 to the power 4 is 16, and 16 times 2 is 32. Fourth root of 16 is 2, and then there is a fourth root of 2 left over. So 2, fourth root 2. And the next ones, you already got a little bit of a hint when I showed you what would happen if we broke it down without the biggest factor. So basically,